Okay, hello and welcome to the Knox Makers Electronic Zone. This afternoon we're going to be building the KM-002 USB powered Holiday Star blinky light kit. We'll teach you a little bit about soldering as we go and how to build the kit, make it work, and maybe do a little bit of debug, troubleshooting if that's required. So hey, the first thing is open up your bag and remove all the components. Should see a circuit board in here, and it has a pre-installed USB jack. Zoom in, give you a little better view. So that's pre-installed. It's a difficult component to solder onto here reliably, so we went ahead and took care of that for you. So you should have a board. You'll have a bunch of LEDs. Different kits have different colors. These LEDs are green. Yours may be a mix of other colors or anything else. A switch and a handful of resistors. And that's a complete kit. So to get started, when we build these, we'll start with components that are the lowest to the board, the lowest profile components, because those will interfere the least as we continue to build the rest of the board. So these resistors, this particular style resistor has color codes. See if you can see that on there. It has color codes that denote the resistance value. You really don't have to worry about that. All of the resistors that are in this kit are all of the same value, and they can go anywhere on this kit that you want. No particular resistor has to go in any particular position. So to use these, what you'll do is just pull them out of this little sticky tape that's on either side. Get them in a standalone fashion. And you can just kind of rip them apart. You don't have to be particularly careful with this. Kind of rip those out. And these are going to be placed in positions on this board as you can see, R9, R8, R10, R1, etc. And the way we do that, we just typically grab the body of the resistor between our index finger and thumb, then use our other hand to bend the leads like so. And you can do that and insert it in any one of these holes. Here I'm inserting it into R9. And hopefully you can see okay there how it's positioned. Then I'll turn the board over on kind of backwards, making sure that the resistor is pushed in firmly from the other side. And then I'll pull these leads out just a little bit and spread them out. Hopefully you can see that. So I've got the lead sticking out on the back side, sort of fanned out, and that is holding the resistor on the front side firmly in place and flush against the board. So that's how you take one of these resistors and put it in place. Now I've got my solder iron heated up. I'm about a 750 degrees Fahrenheit on this iron with a medium-sized tip. Nothing very critical here. Now I'm going to just take this and solder the first lead. And when you solder these, you're trying to both heat up, with the tip of your solder iron, heat up the lead of the component that you're trying to solder and this annular ring, this ring of metal that's on the PC board. You need to heat up both of those. Then you feed some solder in, and the solder, if both of these metal areas are heated properly, the solder will flow. It will wick or flow to both of those. You'll get a good solder joint. So I've got my solder iron tip cleaned off. I've tinned it with a little solder a couple times to make sure it's nice and clean and working nicely. Clean it off again. Now I'm putting the solder tip against both the lead and the annular ring here, the via, and then feeding some solder in. And let it sit there for a second or two so the solder can flow nicely all over the full joint, and then I get a nice solder joint. Yeah, and that looks pretty good. Hopefully you can see that okay. There's not a lot of real critical things here. You can put a whole science project around how to do a proper solder joint, but really for what we're doing here, if you've got a little solder in there and the solder's looks like it's making contact and flowing to both the ring on the printed circuit board and the lead, you're going to be fine. So the second solder joint will do the same thing. So again, I'm making sure the tip is touching both the lead of the component here and the ring on the printed circuit board, and there you go. Looks pretty good. Now we'll continue to do that with the rest of the resistors on this board. So Again, I'll take a resistor, put it between my index finger and my thumb, bend the leads down, and then put it in place on the circuit board. Then I come to the back side. Now I'm holding the resistor against the board firmly on the back side with my left hand. Now my right hand, I'm fanning the leads out again. And you don't need to do these one at a time. In other words, place and solder, place and solder, place and solder. You can place many of these. You could place all of them at one go. Solder them all at once if you want to be a little faster about it. Carefully do them one at a time and spend all afternoon to really get the most out of your kit if you want to do that. It's all up to you. Alright, so I'll continue around the board and do this. Each component. Hopefully you can see that. Typically, I'll include a few extra resistors and LEDs in these kits because you never know, something can happen. One can errantly fly across the room. Something could go wrong when you solder them. They could be damaged. So you'll typically end up with one or two extra of these. We'd hate for one to go flying across the room, the cat carries it away, and then you can't finish your kit. So these resistors are actually connected in series with the LEDs, and they help determine the amount of current that flows through these LEDs. It's a little more complicated than that, but that's close enough for these purposes. A larger resistor will reduce the amount of current that flows into the LED. A smaller value resistor, not physically smaller, but smaller value resistor, will typically allow more current to flow through these LEDs. If you didn't use a resistor, there's a chance the LED would just draw too much current and would blow up, toast and blow up. Depending on the particular LEDs and the voltages and so forth. So I've been around this board and now I've placed all of the resistors in place. I've seen they're all flush on the other side. I'm going to go ahead and solder them all. So I'm going to just tin the tip of my solder iron one more time, make sure it's melting solder nicely, everything looks good, then wiping the tip off, either on a sponge or brass sponge or a wet sponge, whatever you prefer. They both work fine and work equally well. I'm going to go through and solder each of these. And again, each time I'm making sure I touch both the lead of the component, the resistor, and the ring of the printed circuit board. Might have put a little more solder than I needed on there, but that's okay. It's going to work just fine. We're not sending these up in NASA spacecraft. You'll get to see as you do this more and more, you'll kind of get a feel for this. It takes a couple of seconds of heat applied in order to get the solder to flow nicely. We are working here at the Knox Makers facility, and I'm over in the electronics zone, but there's some hard-working termites in the woodworking zone. You might hear some of the table saw noise, joiner noise in the background. I'm trying to give you the full ambiance of working in a makerspace. The usual description you'll hear with these solder joints on these type of through-hole components is it should look like a Hershey's Kiss on the back side. So depending on the actual size of the annular rings of the vias on there and the size of the wire that's coming through and the size of the drill hole and all that, all these things affect the shape of that. On these kits I tend to use a little bit larger annular rings than is really required to make it easier. And we use a wide range of different resistors with different lead diameters coming through here, so you may or may not find that you get picture perfect Hershey's Kiss look on the back, but you probably get pretty close. Okay. So I've got all of the resistors soldered into place. I'm now going to trim the leads off. Okay, I got some side cutters. Going to trim the leads off. Again, nothing magical here. I'm just going to take these cutters, put them flush against the board, and trim the leads off. Nothing real critical here. Just try to cut them flush. And some boards, some PC boards, when you build them, they're a lot denser than this. Components are placed much more closely together, and you might need to be careful that you don't leave much of a tail hanging off of these on the PCB, but it's not the case with these. So at this point we have installed all, 10 resistors? Installed all 10 resistors on this board. I didn't mention this ahead of time, but you may notice that I carefully put the color-coded resistors oriented in a particular way to satisfy my OCD. About halfway done. So, next component we'll do are these light-emitting diodes. So these are the magic light-emitting components. Now these do have to be oriented the proper way. You'll notice there's a long lead and a short lead on these. The long lead is called the anode, the short lead is called the cathode. I have seen diodes that are the opposite, where the long lead is the cathode, but it seems pretty rare. I actually came across one just the other day. But typically long lead goes to the positive or anode, the short lead goes to the negative or cathode. There's a plus sign on this PCB that you'll see, where each of these D9, D1, D2, each of the diodes goes. There's a plus sign on one side. That plus sign is for the long lead. You also can see here on D9, you can probably see there's a line on one side. That is the cathode or the short lead. So plus long lead, line short lead. It's kind of double marked on there. So just take your LEDs, and you do need to be careful with these. You don't want to get these backwards. If you put that LED in backwards, it will not light up. And you'll have a bit of a time pulling the old LED off and getting the new one on. You may have to chop it into pieces, break it into parts. And they're not all oriented exactly the same way. You may see some of them the long lead is to the outside, some of them the long lead is to the inside. So carefully look at each one of these as you place them. So notice there are 10 resistors and 10 LEDs. They do go together. They're placed in series with each other in the circuit. And it's very easy to get one or two of these backwards by accident. Get really carefully you're very careful for the first couple that you do, then it's easy to kind of get in auto place and run mode and accidentally get one backwards. So do be careful. Check each one carefully as you put it in and get it right. It's a lot easier to fix now, a lot harder to fix later after it's soldered into place. Okay. It's got a couple extra LEDs I'll place to the side there. All my cut leads off to the side. Now, just looking to make sure that all my LEDs are flush with the board. They're not sticking out. Nothing looks wrong. They all look nice. All the leads are fanned out on the back. Everything looks great. So now I'm ready to solder them in place. So again, I'm going to pull the solder iron out and put a little solder on the tip to pin it. So what's going on there is the solder has a little bit of flux built into the solder. If you were to cut this in half and look at it under a microscope, there's your tin lead or lead free, whatever the solder type is that you're using. And then there are little tubes of flux in the middle of there, and that flux, what it does is removes oxidation when heated up. So when we put this solder on the tip, you're seeing a lot of that flux burn off and create smoke. It's actually cleaning the tip off. So any oxidation that's taken place on the tip over the last minute or two is cleaned off. So that's why we do that. So put a little solder on the tip to tin it, as we say. Everything looks good. I wiped it off on my sponge. Now I'm going to solder these joints. You'll start to notice as you get more and more components on these boards, these PC boards start to get less and less steady as you solder them. They're going to want to wiggle around underneath. That's why we try to start with the lower profile parts first. Usually helps with that. It's also why I inserted all these LEDs in one go. It's because now I have a whole field of LEDs that's supporting this board on the underneath side while I solder from the top side, so it's a little less wanting to rock around. There are all kinds of tricky vices and things like that you can use to hold these in place more firmly if you choose to. This board's not too bad. Some of them can get fairly unwieldy, real rocky, hard to solder on. But this is pretty even with that field of LEDs on the other side, so it's not too bad. But if you find yourself soldering more and more kits like this, you may find that you want to invest in some kind of vise or mechanism to hold it in place for you. So I'm going to go ahead and clip the exterior leads off here on the perimeter of the board so they're not in the way while I bring my solder iron to the interior LEDs. Okay. So everything's looking good. All right, now I'll go around the inside, solder these down. You may notice as you use solder irons, and especially use different solder irons with different ages and different amounts of care given to them, a lot of people aren't real good about keeping up with their solder iron tips. So you may find that there are some portions of a solder iron tip that take solder really nicely, and you may find there are other portions that don't. So you might just run, when you run solder on your tip, you may find that this tip is in good condition, but you may find that there are some portions of the tip that sort of don't take solder. You can read up on how to try to treat that and improve that or fix it. Usually the main thing I do is just tin it a lot. I just keep running more and more solder over it. If I have some dedicated flux, sometimes I'll just drop flux even onto the tip. It's often just some oxidation that needs to be cleaned off. But if you find that a portion of the tip really doesn't take solder very well, then for the time being you can just solder with a different part. So the part of the tip that is making contact with the board, you really want that portion of the tip to take solder nicely. And if so, then you'll find that you get a good solder joint. You'll be just fine. Then one afternoon when you're bored, you can go back and clean your solder tip so the whole thing works nicely. If you're careful about tinning and cleaning as you work, and you keep your solder iron temperatures lower, try not to run them over 800 degrees. Try to keep the solder temperature in the maybe mid 700s, low to mid 700s, upper 700s, depending on whether you're doing leaded or lead free. You'll find that your tips last longer. They don't get damaged as easily. Don't leave your solder iron running for a long time if you're not using it. And then tin it frequently. Tin it a little bit before you stick it back in its holder to rest. That'll help. Okay, so at this point we have attached all of the resistors and we've attached all the LEDs. Hopefully we put all the LEDs with the correct orientation. They will all work. We'll find out if I did. And the last thing we need to put on is the switch. Now the switch you could actually put either way, the top or the bottom. It really doesn't matter. And in this case there's no orientation. This is all a symmetric component and a symmetric, I'll call it a symmetric latch, not exactly, but close enough. Doesn't have an orientation to it. And you could put the switch on the front or on the back. I prefer to put it on the back because I feel like it makes the front look cleaner. And it's easier for me to get my finger to it. You may choose to put it on the front. Maybe you want your holiday star to sit more flush on a table or something like that, so you could choose to do it on the front. You could really do it either way. I'm going to put this one on the front because we're going to put this on the display here at Knox Makers, and I want to be able to just set it on the table flat like that and have it be obvious that there's a switch on the front for someone to switch to turn it on. Otherwise they may see it from a distance and not realize that. So I'm going to do it this way. Now the switch, I don't know if you can see that or not, the switch is about the same height as these LEDs. You can see there. It's close. Zoom back in here. There we go. It's close, so I can turn this board upside down like this. Let the camera zoom back out, it's in focus mode. I can turn the board upside down like this and solder it, and the switch will be held in place just fine. Sometimes on boards you'll find you need to hold the component with your finger on one side while you solder on the other. In this case, I think we can get away with this just like it is. If you do have to hold it with your finger, just be careful. It's easy to, you'll heat up the component as you solder it, you can burn yourself. All right. So I'm going to put the switch here. It's in place. I'm going to solder these leads. Start with the outer leads. You might find that you have to heat these up a little longer than you did some of the earlier components. It's because that lead is actually affixed to the metal housing, so you have to heat up this metal housing of the switch, where before you just had to heat more of the leads of the diodes and resistors. There's just not as much thermal mass there. And we'll do these last 3 joints in the middle. And these, you know, there's plastic in that switch, so one benefit of doing this last is maybe you've gotten some soldering practice now and you're soldering pretty well. It's good if you can kind of get on and off these joints quickly so we don't stay on there too terribly long and possibly melt or damage that switch. Okay, so we've got this whole thing built now. Everything should be on there correctly, should be all built up, and it should just turn on and work. And does it? Hey, it does. Look at that. Beautiful. So you got a switch to turn it off and on. It's perfectly safe to just leave this plugged up and sitting on your desk and running. Should be fine. You can turn that on, and the way this works, each of these LEDs has their own mechanism inside them that handles the blinking aspect of this. So you simply apply power through a resistor, which limits the current. And then these have their own blinking mechanism. Each of them is slightly different, so you'll see they don't flash in unison. They're each just flashing in whatever timing that they have on their own. And that's it. As far as debugging, so you hook this up, if something doesn't work. The first thing to do is check your solder connections on the back. If you have some LEDs working and some LEDs not working, then you know your power connection is good and your switch is good. Any of the LEDs that are working are probably fine. Any of them are not, then it will either be a resistor or the diode, the resistor or the LED itself that probably doesn't have a good connection on the back. Hopefully that's what it is. So if you find one of these guys isn't working, flip it over on the back and touch up those solder joints right there in that area. If that's not it, then unfortunately you probably have an LED in backwards. If that happens, probably the easiest thing to do, if you don't have, you may have a solder sucker, solder remover, something like that. You can try that method to remove solder. If you don't have such a thing, you can just cut it apart with your cutters here. Just cut the diode into pieces and You can remove one lead at a time. That would probably work. Not the easiest thing to do, but it can be done. There are a lot of YouTube videos on how to do that online. So again, yeah, if most of your LEDs are working, you have one or two that's not, it's either the solder joints or the LED. But that's about it. So, hey, you've got this thing. I've put it on my Christmas tree, let it hang out there over the holidays, put it on my desk at work, show off to people. Hey, whatever you like. So I hope you enjoyed building it. Hope you feel like you got your time's worth and it was a rewarding experience. Hope you learned a little more about soldering, and hope you look at other kits that we've got available and enjoy building some more. Thanks.